Querying is an important operation in DynamoDB. It allows you to filter and select different items in your database based on your application and user needs. When moving to DynamoDB from a more traditional relational databases like SQL Server, it's important that you understand the different ways you can retrieve items in DynamoDB. In this video, let's dive into the different ways you can query data from a DynamoDB database from a .NET application. Hello everyone, my name is Rahul and welcome back to this YouTube channel. I am a software developer working out of Brisbane, Australia and like making videos around .NET, Azure, AWS and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Before we get into the different ways you can query data from a DynamoDB, let's take a quick recap of AWS DynamoDB. I have done a previous video on this channel on getting started with DynamoDB. If you're completely new to DynamoDB, I highly recommend checking that video before watching this one. I also have an associated blog post which will be linked in the descriptions below. Now with DynamoDB, you can set up a table using the AWS console or using CLI tools and also from code. DynamoDB supports two different primary keys. It allows the option where you have just a partition key, which is also called as the hash key, and also the option where you can have a partition key and a sort key. The sort key is also referred to as the range key. Now in this particular example, I have a table which is the weather forecast, which has the primary key as city and the sort key as date. So the data will be entered based on each city's weather data and it will be sorted using the date key. Now when building the API or our application, we will be needing to query the data based on different access patterns. Now in this particular API, all the reads are based from a city name, which is why I have chosen the partition as the city name. Now in your application, you'll need to choose the appropriate hash and the range key based on your application's data querying needs. That is a topic for another video. Here in my AWS console, I already have the table created. So if I navigate to DynamoDB and under tables, you can see the weather forecast table. This also has the partition key as city name and the sort key as date. Now, if we navigate further into the tables, you can explore the table items. Now this shows you the items in the database. I have pre-populated this database with some data, which we can use while we query the database. As you can see, we have data for Brisbane and Sydney in this particular database right now. Now let's switch over to Rider, which is the IDE that I will be using today. Now you can choose any IDE of your preference as well. Now this is the application that I used in the getting started with DynamoDB video. I have made slight modifications, which I'll walk you through now. So we have the program.cs, where we have the Amazon DynamoDB and the DynamoDB context being injected into the application services. This is used for the dependency injection into our controller classes. Now in this particular case, I am using the fallback credential factory to get the credentials that will be passed into the DynamoDB client. Now since I have installed AWS Toolkit for Rider and I have set up the credentials to my account, it will automatically connect to my AWS account. This allows me to query the data from my AWS account and this particular DynamoDB table that I just showed you before. Now, if you're completely new to setting up the AWS Toolkit and the credential loading, I highly recommend checking out my video on getting started with AWS credentials. I also have the weather forecast controller, which is the controller that exposes the different API methods. We will be adding more methods based on the application querying needs. Now in this particular case, I have one HTTP GET, which is the specific date endpoint, which gets the data by a city name and the date. This already has the DynamoDB context injected into the controller, so we are using that to load a specific item. Now the load method retrieves a single item from the DynamoDB database. To do this, you need both the primary keys that you have set up on the table. Now, if you just have one primary key, which is the partition key, then you can use that as well. Now, in this case, I have the city name and a date, and it loads a specific item from the DynamoDB database. Let's run this application and make sure this is working as we expect. So let's run this. This launches the Swagger API endpoint as expected. So let's go into our get endpoint, try it out and specify the city name. And also let's specify a date. So let's choose 2023-02 and 01, which is the 1st of February, and click execute. This returns the data as expected and it returns only one record. So you can see this is for the date 02, 01 and 2023, and it shows you the temperature on that particular day. Now if we come over to the items list here, let's also copy one of these dates and use that in our query. So let's come back and update this date to be that and click execute. Now in this case you can see it's returning 26, which is exactly the temperature on that day in our database. Now as you can see, the return data also has a temperature Fahrenheit property, which is currently not saved in the database, but it's just calculated in our controller class. So if you look at the weather forecast object, this has the conversion inside here. So this is not getting saved into our database. With the application set up and running as expected, let's get into the different querying patterns that we come across usually when building APIs and applications. One of the reasons why querying can be a bit tricky with DynamoDB is that you always need the hash key to get the data out of the database. While there are ways without that, it's usually not recommended and it impacts performance as well. So it's always recommended to have the hash key when you are querying data from DynamoDB. This is why it's very important to choose the right partition or the hash key when building up and setting up the database in the first place. So let's say we want to add an API endpoint which can be used to get all the weather data for a particular city. So let's specify a new HTTP GET attribute and also let's specify the route for this particular case. So let's call this as city-all. This is going to retrieve all the city data for that particular city. So let's specify async task, and in this space we are going to return an enumerable of weather forecast because there's going to be multiple records, and get all for city. And let's pass in the city name. So this is going to be string and city name. Now in this particular case, we cannot use the load async because this just returns one data. So let's use the different method from the DynamoDB context and specify the query async method. This is what is used to query the data from DynamoDB. In this particular case, as you can see, it has two overloads and both of them takes the hash key value as its parameter. This is why it's important to have the hash key when querying data from the database. And in our case, the city name is the hash key, which is why I am passing in the city name. So let's specify the query async. Let's specify the type. So in this case, it's weather forecast, and let's specify the city name. Now this is going to get all the data for this city from the database. Let's also make sure to call the get remaining async on the return object of the query async. The query async returns the type of async search of t, which is in this case is going to be weather forecast. On this async search, we have the method get remaining async, which is used to get all the objects from the database. So once we have made this call, let's return this data as normal. Let's also make sure to add the await keyword because this is an asynchronous method. Now once we have set this up, let's run this application and make sure we have everything working as expected. Now it launches the Swagger UI. We have the new city-all method. So let's try this out and let's pass in Brisbane as our city name and execute this. Now this is going to return all the objects from our database. Now you can see there is a lot of data for different dates from our database getting returned. Now we have successfully added a new API endpoint to get all the weather data for a particular city. Now let's say we want to further filter this data based on the date, because this particular call is going to return a lot of data as our database grows. Now let's say we only want the data for the last month or maybe for the last 2 months. In these cases, you most likely would be passing in a date. So let's add in a new HTTP GET method and let's specify the route. So let's specify city date filter, which is going to use the date as a filter, and let's specify the method in here. So let's again specify the same structure. So it's going to be an enumerable of weather forecast and gets all for city and date. So let's pass in the city name in this case, and let's also pass in a date time, which is going to be the start date. So let's use the same DynamoDB context.queryAsync method, and let's pass in the weather forecast, and we can use the overloaded method in this particular case. So let's pass the city name, which is the hash key as before, and we can use the overloaded method, which takes in a query operator in this particular case. This acts on the range key or the sort key. As you can see, based on the name sort, it actually sorts the data on that particular key. So let's use the query operator greater than, and let's specify the values. In this case, it expects it as a new object array. So let's pass in a new object array of data. And in this case, we will pass the start date. So this is specifying a query operator as greater than and passing in the start date as its parameter. Because greater than has only one object, we just need to pass in one parameter. Let's also make sure to call the get remaining async so that it returns the data as expected like before. Let's make sure to close the angle brackets and run this to make sure this is working as expected. We have the new method added in our API, so let's expand this. Let's specify the city name, so in this case Brisbane again. Let's specify the date, so let's say we want all the data after February 1st, and let's click execute. Now this is going to return more data, but as you can see, this has only data starting from February 2nd because we had specified greater than. So this is having the data from February 2nd, 3rd, 4th, and so on. Now we have successfully able to filter the data from our database. Now if we give a different date, let's specify as January 25, and it's going to return data from the January of 26th. This is because we had used greater than. Now if we come back to our code, the other operators that's supported are between, equals, begins with, greater than or equal, less than, and less than or equal. So based on your application and API needs, you can use different query operators. Now in the case of between, you will need two different dates. So let's create that as a different API endpoint so that we can test that as well. So let's specify date filter 2, which takes in a date start time and also a date time as end date. Now in this particular case, we will be using between instead of greater than, and we have to specify the two dates. Now all we need is to pass in the date in the same order. So let's specify the first date and the end date as in the same order. And let's run this again. We have the new method filter2. Let's expand that and let's pass in the city name, the start date. So let's specify 2023 02/01, which is February, and let's specify 02 and 04. So it just returns the data between the 1st of Feb and the 4th of Feb, and let's click execute. Now in this particular case, you can see this has the data starting from 021, 022, 3, and 4. And we have filtered out all the remaining data. Now if we want a different start date, let's say we want to get from January, so let's pass 25th of January, and it starts returning us data based on that particular range. Now let's say we need an advanced filtering scenario where we want to further filter this data based on the temperature as well. Like we are interested only on the days where the temperature was greater than 30. Now in this case, we need to filter the data based on a property that is not a primary or a hash key. If we come back to our code, you can see the query async has only two overloads and does not have an overload which supports this feature. In this particular scenarios, we need to go down to a lower level API that is also provided by the .NET SDK. Until now, we were using the DynamoDB context, which is a wrapper over the DynamoDB client. So if we come back to the program.cs, you can see here the DynamoDB context is actually wrapping around the Amazon DynamoDB client, which provides the lower level APIs. Now if we navigate into the DynamoDB context class, you can see this already takes in a DynamoDB client as its parameter. So if we look at the constructor, you can see this is taking in a Amazon DynamoDB. So this is giving higher level API features on top of the Amazon DynamoDB, but it is also removing a lot of features. Now for the advanced filtering scenarios, we will need to use the Amazon DynamoDB instance directly. So let's create an instance of that into our controller and start exploring how to use the lower level APIs. So let's come to the constructor. Let's inject in Amazon DynamoDB, call this as DynamoDB client, and let's inject this into our class. So let's introduce a read-only field so that we have the DynamoDB client. Now to start using this, let's create a new HTTP GET method. We will first explore how to create a similar experience where we can get all the data using the city name using this lower level API. So let's create a new method. So let's call this as HTTP GET. Let's pass this route as city name and let's specify low level. So let's specify public async. We will be returning a task of enumerable of weather forecast again. I have an extra bracket, so let's remove that. And let's say get all for city low level. Let's pass in the string city name. And let's use the new DynamoDB client. So let's look at the underscore DynamoDB client. This has the method queryAsync again, but as you can see, this takes in a different object. Now this needs a query request as its parameter. So let's specify the query request. So let's specify a query request object, which we will be creating shortly. And let's create a new query request right above this. And this is going to be of type query request. So let's pass in the appropriate values for this. First, we need to specify the table name. In this particular case, the table name matches the weather forecast class. So let's use the name of and pass in the weather forecast. Now the DynamoDB context was using conventions to automatically do that for us. Now once we have the table name, we need to specify the key condition. So let's use the KeyConditions property and let's create a new dictionary of string and key conditions. This is used to pass the conditions on which we need to filter the data. Since this is a dictionary, let's create and pass a key value pair. Now the key condition is based on the city name. So let's use the name of again and use the city name in this particular case. So once we have the name, let's also pass the condition. So this is going to create a new condition object, which then needs additional properties. So you can see I need to specify the comparison operator. In this particular case, the comparison operator is going to be equals. So we need all the places where this particular city name property equals a specific value. Let's also pass in the attribute value list, which is going to be again a list of attribute value objects. Since that is a list, let's create a new attribute value and pass in the string value, which is going to be city name. Now that is a lot of code that we had to write, which is simply replaced by the DynamoDB context by a single method. Now this is why the DynamoDB context wraps around and gives us a higher level API. Now with the query request defined, let's make sure to close this. Let's get the response. So let's say where response is equal to await and let's make the call. Now the response in this particular case is of type query response. This has the property items, which has the list of string and attribute value pair. We are not getting strongly typed weather forecast objects here, but simply a dictionary of values. Now this is exactly the same way DynamoDB stores the data in the database. So if we navigate to the items and navigate further into one of these items, you can see this in the JSON view. So we have the objects as a dictionary of key value, which is a JSON format. This is how DynamoDB stores it in the database as well. Now if we come back to our code, we need to convert this particular list of items into a .NET type. Now the easiest way I know to do this is to iterate these items, which is the dictionary of string and attribute value pairs. So let's use the select method to iterate through each of these items, and let's get the item, and let's use the document model, which is another level of abstraction that the SDK provides us. So let's use the document dot and specify the from attribute map, which takes exactly the string and attribute value pair. So let's specify that method, pass in the A, and this method returns us a list of documents. Now from these documents that is returned, We can again iterate over the list or simply write it inside the same select method. So let's open start braces. Let's specify where doc is equal to retrieve the document, and we can use the higher level context, which is the DynamoDB context, and specify the from document method. So we can specify a weather forecast and pass in the document that we retrieved from the previous method. Now let's return this. In this case, this is going to convert this particular attribute map into the weather forecast. Now if we look at this again, we have the response.items, which is of type list dictionary of string attribute values. We use the document class, which is another SDK API in the same Amazon DynamoDB NuGet package, and we specify the from attribute map. This converts this particular dictionary of values into a document type. We then use the DynamoDB context, which is the higher level API, and use the from document and pass in the weather forecast and the document. This returns and converts it into the C# type. Now there might be other ways to do this, but this is what I have found the easiest. So let's use this for now, and let's return the data as expected. So let's return this. Let's run this to make sure it's working as expected. So let's put a breakpoint here to also debug and see the items that's returned. Now the API is running. We have the new method, which is the city name low level. An L is missing there, but let's pass in the city name. So let's specify Brisbane and let's click execute. Now this hits the breakpoint as expected. Now you can see the response.items. So if we expand that, you can see this has a dictionary and a string attribute value. Now if you expand each of these, you can see the different properties inside this. So we have the date, the temperature C, and also the city name. Now if we expand further the value, you can see only the S would be set up on Brisbane. Now if we expand the temperature C values, you can see it is the N, which represents that it is a number and that value is set up. Now this is exactly the same way DynamoDB also stores the data. So you can see here temperature C has N and it specifies the value as a string, whereas the city name is a string and it specifies the value as its value. Now once we have the items, it is looping through the documents. So if we put a breakpoint inside the loop, so let's get the document. So in this particular case, we get the document object, which is another representation of the same data. Now in this particular case, this has the key and the value inside it. Now once the document is created, it's using the DynamoDB context, converting that document into the weather forecast. So let's remove this breakpoint and continue execution. Now if we come back to our API endpoint, you will be able to see the data as expected. So we have retrieved all the data for that particular city. Now specifying the key conditions was a bit of code, which is why the KeyConditions property is now a legacy parameter, and it suggests us to use the KeyConditionExpression. So let's see how we can use the KeyConditionExpression. So let's fix this name with the low level. Let's copy this and create a new endpoint so that this code stays there for your later reference. So let's copy this and let's create a new method. Let's name this as low level expressions. Let's also rename the function name so that there's no conflicts. Now instead of key conditions, we can specify the key condition expression. So let's remove this key conditions property, which takes away a lot of code, and let's specify the key condition expression. In this particular case, the expression can be represented as a string. So in here, we want the city name to be equal to, and we need to pass the parameter value. Now in this particular case, we need to pass in placeholders for values. So we will be passing in as city name, the value for which we will pass in with the expression attribute values property. So we can create a new dictionary of string attribute values and pass in the data as part of this. Now here we need to specify a key for which we are specifying the value. In our case, we are passing it for the city name. So let's specify and give city name as the dictionary key name. Let's also specify the new attribute value. Now since this is a string, we can simply specify it in the constructor. So we have the city name, which is the value that's coming from our API parameter. So all we're doing in this particular case is specifying an expression which says use this particular expression to query the data. And we're specifying the value for the city name as the expression's attribute values property. The rest of the code that retrieves the data and maps it remains the same. So let's run this and make sure this is working as expected. So we have the new endpoint created. So let's pass in the city name. So let's pass in Brisbane and let's click execute. Now this returns the data as before. It returns all the data for that particular city. Now let's say if we want to filter this again by the date. So let's use the same method in this particular case. So let's specify the date time and pass in the start date. Now in this case, we can update the key condition expression because the date is also a key. In this case, the range key. So let's specify and, just like you would specify additional conditions in SQL, and let's specify the date property. So let's specify date equals, and let's pass in the value, which is going to be the start date. Now, since we have a new placeholder being passed, we need to add in that value as well. So let's create a new row in here, specify start date. So I just used Control D to duplicate that row, and let's pass the value for start date. Start date is also stored as a string. So let's use start date to string. And we can use the AWS SDK utils class to retrieve the date format. So this uses the ISO 8601 date format. So let's make sure the date is formatted as expected. Now let's run this again to see if this is working or not. So let's debug this. Let's expand the low-level expressions. Let's pass in the city name and let's pass in a date. So let's say 2023, 02 and 01. And let's click execute. Now in this particular case, we have retrieved back an error. It says invalid key condition expression and the attribute name is a reserved keyword. And the reserved keyword is date. Now DynamoDB has a set of reserved keywords and you cannot use these in the names in the expressions. So since we used a reserved keyword, which in this case date, so you can scroll down and you can find date inside here. And we have used that inside the condition expression. This is not supported directly. Now, because of this, if you want to use these names, you can define an expression attribute name and use that in the place. So like we used the attribute name for the parameter values, we can also pass the value as an attribute. So instead of specifying the date like this, we can specify hash, let's say start date. So just to differentiate between the parameter name and the value, I have used hash. Now in this case, we need to pass this as part of the expression attribute names list. So let's create a new dictionary of string, which is simply a mapping from a string to a string. So in this particular case, we need to map the hash start date to be date. So let's pass in a string hash start date. And let's map this value to be simply date. This allows us to use the property date, which is a reserved keyword, inside the condition expression. Now this is only applicable for reserved keywords. If the range key was not a reserved keyword, you could have directly used it here. But I just wanted to show this as an example. So now if we run this again, so let's debug this. We have the method here. So let's try it out and let's pass in the city name. So which is Brisbane. Let's use 2023, 02 and 01 and click execute. Now this returns an empty list. This is because I used an exact equals inside the condition expression. So let's stop this and let's make sure to specify greater than so that it returns all the data after that particular date. Now if we had passed in the exact date, we would have got the single item from that particular date. But let's come back again. Let's run this application and run this with the greater than symbol. Now let's expand this again. Let's try it out. Let's pass Brisbane. Let's specify 2023, 02 and 01 and let's execute again. Now in this case, since we used greater than, we get all the data greater than that particular date. Now we started down this low-level API path because we wanted to filter the date based on additional properties. So let's say we want to also use the temperature to filter this data on. Now to do that, let's modify this particular method, which is using the low-level expressions. Let's also pass in the minimum temperature. So this is the minimum temperature and we only require the data after that. Now similar to the key condition expression, we can add in a filter expression for this. So we are filtering the data after the key conditions are met. Now in this particular case, we have the temperature C property. So let's use temperature C, and this needs to be greater than or equal to the value. So let's specify that as a parameter again. So let's specify minimum temperature, and let's pass the value as part of the expression attribute values. So let's duplicate this. I'm using Control D. Let's rename this to be min temp, and let's pass the value as minimum temperature. Now in this particular case, the attribute value is a numeric. So we need to specify n and set that property accordingly. So let's specify minimum temperature on n and convert this to a string because n is a string property. So once we have this passed in, the filter expression should also start working. So let's run this again to test this. So we have the new minimum temperature in here. So let's pass in Brisbane. Let's pass in the date. So 2023-02-01. And we want only the data above 30. So let's execute this. And we get just 2 records back on the days where the temperature was 30 and above. So if we pass in a lower value, let's say 25, we get more records. So you can see there is one which is 28, 30, 25, and 30. Now you can also use the between operator, which has the start date and end date, or even update the conditions as you require for your application. So let's stop this. And if you want to use between, you can use start date, and let's specify between start date, and you can specify the next value, which is going to be the end date. So let's make sure we pass in the end date as well in the parameters, and let's pass in that value as part of our attribute value. So instead of start date, let's specify this as end date, and let's convert the end date here. Now if we run this again, our method has an additional property. So let's try this out. Let's give this as Brisbane. Let's give a start date. So let's say 2023-01 from January 25th. And let's specify 2023-02. And let's specify 3rd of February and over temperature 25. And let's click execute. Now this returns data between those 2 dates and only for those specified temperatures. So we get much more data. As you can see, we have one from January and also from February. Based on your application needs, as you have different filtering needs, you can update the properties and the expressions inside here. Now in all these cases, we queried the data with the hash key. Now this is the recommended approach and also the one that's more performant. Now you can do a table scan on DynamoDB using the scan functionality. So let's see the last example as that. So let's specify a get HTTP. Let's specify a scan as the method. So let's say weather scan because it's going to return the weather data. Now let's return a list. So as before, public async. Let's return a task of IEnumerable of weather forecast. And let's make sure to name this as get scan. So now this does not need the city name because we are scanning the entire table. So now let's use the scan function from the DynamoDB context. So you can specify the scan async method. Let's specify the weather forecast, and that is all that we need to specify. So we can also call the get remaining async and return this data as expected. Now the scan async method expects a list of scan conditions. For now, let's simply pass in an empty array. Now let's also add the await because this is an asynchronous method. Now let's make sure to fix this by passing in the appropriate type. And let's run this to see how this works. So let's debug this. We have the new method, which is weather scan. So let's expand that and let's simply try it out. Now in this particular case, this returns all the data in our DynamoDB database. So if you keep scrolling down, you can see data from Brisbane, and you can also see the data which is in Sydney. Now this has scanned the entire database and returned all the items inside that. Now right now, I only have a few items inside the DynamoDB database. So if I go to the tables, go to the table summary, you can see there's just 40 items. But as your table grows, this is going to scan all the items inside the database and return them one by one. Now you can also add scan conditions on that, but still the performance is bad because it needs to scan all the items one by one. So if we add a condition, so let's specify the condition as new scan condition, which takes in a property name. So we can specify name of, let's use the property weather forecast.temperatureC. Let's specify the condition is greater than, so scan operator.greater than, and let's pass in a list of values like before. So let's specify new object array, and let's pass in the value 25. So it returns all the data that's greater than 25 degrees. Now let's run this again and see how this is working. So let's expand this, let's try it out, and let's execute. Now we get back only the data which is greater than 25 degrees Celsius. Now this is still a reduced list, but it is actually scanning through all the items in the DynamoDB database to filter down those values. So where possible, do not use scan, but prefer to use the query with the hash key and the appropriate filters, etc. You can also add indexes to DynamoDB, which we will cover in a separate video. We will also cover about indexes in DynamoDB, and if you want to learn about that, please do drop in a comment below. I hope this helps you to understand more about querying data in DynamoDB. We saw the different options on using the query function and also the scan function. We learned how to use the high-level DynamoDB context and also the lower-level APIs using the Amazon DynamoDB client to get the data from the DynamoDB. As our filtering needs advance, we are forced to step down to the lower-level APIs. But specifying the key condition expression and the filter expression, you can filter a lot of data in DynamoDB. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.